All right, let's have a look at this question over here. Okay. So, question says, okay, you're given the following information. Okay, the probability of X and Y is equal to the probability of X is equal to probability of Y is probability of not X and not Y. So just a little reminder about independence, because that is going to help us with this sentence over here. Well, the only way you can have the probability of not X given Y is equal to the probability of X is if they are independent events. Because if we think about it, the formula for probability of Y of X given Y has occurred. The formula for that is probability of X and Y over the probability of Y. And the only way you can get that to be probability of X equal to probability of X is if, in fact, the probability of X and Y is equal to the probability of X times the probability of Y. Okay, and then the probabilities of Y's cancel out. Okay, and you're left with the probability of X. So in general, okay, if the probability of X given Y is equal to the probability of X, it means that the events are independent events. So really, you didn't have to do what this whole bit over here. Okay, but I would start with this. The probability of X given Y is equal to the probability of X, which implies X and Y are independent, which implies the probability of X and Y is equal to the probability of X times probability of Y. So now you know. By the way, I did this completely different to the memo, but I got exactly the same answer. So there must be something in what I did. Okay. So probability of X and Y is equal to probability of X times probability of Y. Now, they said to us, I just said, let A be equal to the probability of X, all the things that we're given. Okay. So now we know that the probability of X and Y is equal to the probability of X times the probability of Y. But those are equal to A, so the probability of X and Y is A times A, which is A squared. Right. So probability of X and Y is equal to A squared. So then what I did was I drew a Venn diagram. Okay, and I had X and I had Y. Okay, and I started with the inside, probability of X and Y is A squared. But they also told me that the probability of not X and not Y. Well, not X and not Y, okay, both have to happen. In other words, it has to be neither of them. It's that space over here. So probability of not X and not Y is also equal to A. So I've got that is A squared. That is A. Now the probability of X, okay, must, okay, that whole probability has to add up to A. So this bit over here must be A minus A squared, because A minus A squared plus A squared gives us a total for the probability of X as being equal to A. Okay? And then likewise, the probability of Y is also equal to A. So if that is A squared over there, then A minus A squared plus A squared, okay, this has to be A minus A squared, so that the whole probability of Y adds up to A. Now, if I take all of those things in that diagram, and I said A minus A squared plus A squared plus A minus A squared plus this A, that all has to be equal to 1. And if you simplify it, you end up with 0 is equal to A squared minus 3A plus 1. Then you simply go use the equation mode of your calculator. And the one answer is 0.382, and the other answer is negative, and it's probability, so it can't be negative. So your final answer, probability of X, must be equal to 0.382. And that is the end of the paper. Hallelujah. Okay.